Today I'm going to demonstrate the new beam analysis features we've added to version 9.1 of LORENTZ. I'm using a model of a pair of quadrupoles with a surface emission of 120 rays, and you can see that with this large number of rays it becomes difficult to interpret what is happening inside the beam. So we've now enabled you to define a beam axis. So I'll show you that using trajectory, physics, and beam axis. We have a beam axis definition dialog box. You can define the beam axis using any of the principal axes or any collection of connected segments. And you can specify an origin. I have chosen 0, 0, 0 for my origin, which happens to be a distance from the actual source of emission. Once you have defined the optical axis and once you've performed the trajectory simulation, you can then use the beam display along axis box to analyze what is happening. So you can create scatter plots or contour plots. You can plot the current density, linear charge density, time, energy, power, velocity, momentum, or number of rays. We'll do a scatter plot of the number of rays. And we'll do that right at the origin of my beam axis. You can see there the distribution is circular, and we'll move a little bit further along the axis. So now you get a good feel of how the beam is being focused along one axis and defocused along another. And instead of just entering distances along the axis in this box, you can pick points using the mouse. Now I'll show you how to construct a contour plot. We'll do a contour plot of the current density. I'll make it a solid color plot. And again, we'll start off right at the origin. You'll notice that the highest current density is shown in red. Again, we'll start moving along the axis and creating further plots. And we can just start picking points too. You'll notice that as the beam becomes more compressed, the color coding of the previous plots changes, because as the beam becomes compressed, there you're seeing the higher current densities, and the original plots now will have lighter colors to indicate that they no longer have the highest current densities.